Hello CIS18A, this is part 2 of week 4 lecture. In this part we will talk about recursion, static block, nested and inner class. So to start, we're going to talk about recursion, and recursion simply is a method that calls itself, and you would see this in mathematical example in Fibonacci. Sometime we would use a method to regenerate something over and over again, building on the previous value. So the key component of the recursive method is that it would execute a call to itself. And now in computation, if you were looking at like factorial numbers, or you're looking at something to be able to like Fibonacci number, Lucas number, you would see recursion being used. Now the beneficial side of recursion is that in a way that we can implement it, and it's simply implemented. However, when you're looking at to generate a larger data sets, you're going to run into issues, as it's going to be slower if you're looking at to be able to calculate out to the hundreds, or even a higher range number. So in the example that's shown here is to find factorial using recursion, and we would have a function or a method called factor, and then the value as the result is going to store into a variable called result, and that's part of the factorial class. Then we simply implemented the if statement. If n is equal to 1, return 1. And normally you would see that it's going to start at 1 because factorial of 1 is 1. And the result is going to store factor. We're going to call the factor here n minus 1, and that would execute the recursive call. So we would see that the n is the position of the number, and minus 1 is going to be the previous position of the current number times n. So if we're looking at factorial of 2, we would take 2 times 1, and 2 is n, and it's going to multiply it by the previous value, n minus 1, which is 1. And so 2 times 1, that's going to give us 2. So we want to return the result. And we want to continue to do this, as factorial of 3 is 3 times 2 times 1. So we would have, 3 multiply it by the previous result, multiply it by the prior number, which is 1. So now in the iterative process, we would start out with fact I, and that's going to give us the placement or the position of that number, and then int n. And so for the int I and the int result, that's going to be implemented for our for loop here. So result is going to be initialized at 1. We're going to have a for loop. We're going to start at 1. We're going to go up to the n value, and we're going to increment each time. So the result is going to be result times t. So we're going to multiply it by the previous result to be able to get the factorial value. So here, that is really the algorithm part of the factorial program. The second part of the program, the second class, is called the recursion class, and under that you have a main method, and we construct the object f with the new type, so that would be part of the factorial class, and then we would use that object to be able to call the method inside the print line. So here what you have is you would have the first line that says factorial using the recursive method, and then factorial of 3 is, and it's going to be 3 times 2 times 1. So it's going to output. So we're going to call the factorial. We're going to access factor using the f object here, and we're going to put in past the value here, 3, 4, 5 for each one. So now for the iterative method, which is when it's going to use a for loop, and the iterative method sometime would be used, we would be using the same value 3, 4, 5. So you should get the same result on both sides. With the recursion, it's going to show factorial 3 is 6 as the same in the iterative method. So when you're using loop, that would be considered iterative method. But when you're using the recursive method, you simply use it, it's a method that's calling on itself continuously as it would span out to the value of n. So here what we have is we have the same output, and the explanation is follow on how you would use recursion. And recursion is used across all languages, C++, Java, Python. So then what you have is you have to be able to grasp the understanding that you can create a method and use that method continuously and use the method to call itself to make it recursive. So the main advantage of this is going to be the type of algorithm that's implemented is more clearly, simply recursively than they can be iterative. More often you would find that recursive function is used for mathematical computation because it's a little bit more clear. Or sometimes you would see it in something like a quicksort algorithm would be more difficult to implement it with iteration or iterative using loops. So there are different preference in how the program would be created based on its programmer, but however, the disadvantage of recursive calls would be that the stack it's going to reach the ceiling of the stack. The stack is going to overrun. So like I mentioned earlier, when you are working to build a larger data sets from the algorithm, you would reach the ceiling of the stack, and so that Java runtime will cause exception, or it will halt, or it just gradually slow down and it would not be able to produce result. So that's the downside of recursion. Now, when writing recursive function or methods, it's important to keep in mind that you need to have a conditional statement. That's what we see earlier, where we would have that if statement. And so with that statement, it's going to return without the recursive call. So we would say if this is equal to 1, it's going to return 1. So it's always that you would see recursive function or method that would start with the conditional statement. If you don't do this, it will never return. So in the case of the error, which is very common in recursion, you want it to be able to print, and so that way you can expect some form of exception with the recursion, and so that way if there's some error or exception, you would be able to abort the execution to avoid mistakes. So the bullets here give you some of the things, the main points behind recursive call, and also the recursive call does not make a new copy of the method. It's just reusing the same method over and over again. It's calling itself, and the benefits and the disadvantage of the recursive call. So that is one of the important sections in all programming classes. We would address that and compare that recursive function or recursive method compared to iteration. And in the higher classes, you would revisit the topic. So it's important to understand this, be able to practice and write recursive call. So in the next section, I'm going to talk about using static. So when you define a class, each of the member, like a variable inside that class, can be used independently with any of the object in the class. Now, you can also use the object to access method like we talked about earlier, but it is possible that you can create a member that can be used by itself without reference any other instance. And in this case, it would precede using the declaration or the keyword static. So with static, it can be accessed before any objects in the class is created. So what happens is this is instantiated before the object without any reference to the object. So it is independent. And you can also declare methods and variables as static. So when you use the keyword static, automatically for Java, that's going to specify that could be a member or a method, a member method that can be accessed before any of the object is created, and it doesn't reference any object. It is independent. Now, for outside of the class, you can use static member. You only need to specify its name, or its class name, following by the dot operator. So you don't need to have any object created. So when you're using static, you don't need to have object created, where before we talked about how your class members and the member methods, you need to have an object to be able to access it. In this case, if you're using static, you don't need to have the object created. So on the bottom of below that, you would see timer.count, and we can initialize it as 0. So in this example, 10 is assigned to a static variable named count, and it is part of the timer class. So you would see timer.count. Timer is the class, and count is the variable, and 10 is its value. Now, so for the format, static method can be called the same way using the dot operator with the name of the class. So when you declare the variable, you need to include static, essentially global variables. When your object is declared, no copy of the static is made. It doesn't make a copy. Instead, the instances of the class it shares the same static variable. So it's using that same static variable instead of making the copy. So on the next section, it shows you the example in Java. So we have a class called static demo. It has X as a member that holds integer. So this is your normal instance variable. Then static int Y, this becomes a static variable because we see the static is listed here. Then in the next section we have int sum, and this is going to be the method. We're going to return X plus Y. So for class demo, we have the main method. We created the object OB1 and OB2. We constructed that. And we're going to use OB1 to access X. Remember, X is the normal instance variable, and OB2 to access X, which is now 10 and 20 for 1, and 10 is for 1 and 20 is for 2. Then we print out, we're showing that they are independent. Now, in the next part, we then would use static variable, which is then we shared the variable Y. So here, notice that we have static demo, and static demo is from the first class. This is the class name, and then Y is the variable name, and we initialize that. We assign that at 19. So here we simply print out the string, set static demo Y to 19, and we then lastly would have the object 1, OB1 and OB2, and we call the method here. We access the sum to do X plus Y, and then to be able to print that. So in this one, on the next part, we then update the static y, the static variable y, to 100, and then we also calculate the sum after we updated it. So the first one, of course, we have x is 10 for the first object, and the second object, OB2, is 20. Then we would take 19 plus 10, we get 29. 19 plus 20, we get 39. Then for the third one, since we updated y to 100, we would have y plus x, which is 110, and y plus x again, which is 120 for the second object. So here you can see that the static variable y is shared both OB1, it's shared by both objects, and it changes its effect for the entire class, but not as an instance. The difference between the static method and the normal method is that when it's called through its class name, it can be used without any object that is created. So you don't have to have the object created when you're using the static, and if you're using the static method, you also don't have to have the object to actually call it. So in the next part here, it shows you the static method. We have a class called static meth, and here we would have a static variable, int val, that's a static variable, 1024. The static method, we use the same thing, static key, the type of the method, and the method name. Then we're going to return from that. So in the second class, we simply use the main method to be able to call the actual static method. So here we simply print the static meth.val to be able to access the val, which is 1024, and also to do the calculation 1024 divided by 2. So notice that we didn't have to have an object if we use the static. So compared to all the other programs that we touched on in the last chapter or last couple chapters, we have always discussed creating the object, using the object to access the method. In this case, you don't need to have the object to access the method. You're simply using a static method, and you will be able to call that to operate. So that is how we would be able to implement that. So when the methods is declared as static, there's some restriction. They can directly call only other static methods in its class. Okay, that's important to note. They can only directly call other static methods in its class. They can directly access only static variables in the class. So the static methods is to access static variable, and static methods can only call static methods. And those are two important points to highlight. You cannot have mix match. So if you plan to use object, you can simply use the object to access regular method that you declared in the class, or if it's public, then you can access it from a different class. Then if you are using static methods can only call static method, and static method can only use static variable, and that's important to remember. So next, it shows you an error on where you would have the instance variable with the static variable mixing with the static method. That won't work. It's going to throw an error. And one of the third things that I forgot to mention, that they do not have the this as reference, so you cannot use this. So what do we mean by a static block? It is executed when the class is first loaded. It is executed before the class is used for any purpose. So static block is executed first before the class is loaded. So what we can see is that when you have the static block, you would use the keyword static here, and you notice that there's a curly brace, and then inside it, this would be the body of the static block. Okay. Now, why do you really need this, right? Sometimes you want to be able to have this initialized or executed before creation of any object. Something like establishing connections to specific remote site, like the example talks about here. So you wanted to have the static block before it actually execute anything else in the class. Okay. All right. So that's an example where it shows you the static block, right? And so this is going to come first before the class itself. And you don't need the object for that. Next, I'm going to talk about the nested and inner class. So you can have a class within a class. A class is declared within another class. That would be considered nested. And so with the nested class, it does not exist independently from the closing class. So if you are nesting a class, it would not work without the outer class. The nested class is declared directly within the enclosing class scope and the member of its enclosing class scope. So when you have the inner class, the members of that is going to be dependent on the outer class, which is in a larger scope. So it is possible to declare a nested class that is local to the block, and there are preceded by static modifier, and there could be non-static. So the non-static variety is called the inner class, which has access to all variables of the methods of its outer class, and that can refer directly to the same way as a non-static member. So if it's in the inner non-static variety, the inner class, it would have access to the variables of the outside and the methods of the outer class. Now, sometimes the inner class is used to provide the set of services that would be enclosing, that would only be with the enclosing class. So here is an example of the inner and outer class. So for the outer class, we have these variables. You have the instance, or you have the array int nums, and then you would have the outer that would be int and array, and then num. So the inner class, you have int min and int m. So the inner class is going to be nested within the outer class. Now, with this is that you would be able to access from the inner to the outer. Okay, so it shows you there that we have the inner class inside that class, and that class is working with another class. So what you have here is you have a for loop in the inner class, and you're going to use the for loop to be able to iterate through return m. For the max is a method, and we wanted to be able to determine the maximum value and the average same way. So we would iterate through the array. We're going to find minimum, maximum, and average. So now notice that in the inner class, we simply just have the method. In the outer class, it has the array. So what we're doing is we're using the method to access the array on the outside, the outer, to be able to iterate through each of the element of the array to determine the min, the max, and the average. And that's what's happening here when you nested the class. Then for the second class, we simply have the main method. We initialize the values for the int x array. We construct the object called OB, and then we simply call analyze. So with this is we're using the main method to initialize the value for our array, construct the object, and call the method. So, and with the analyze, what will happen is analyze is happening on the outer class, and it's gonna trigger, right, the inner class to be the inner method to be able to access the outer array. To provide in analyze, we simply print min, max, and average. So this is the way that we can nest. The inner class have the methods to determine minimum, maximum, and average. The outer class has the array that would be accessed by the inner method, and the outer class has a method called analyze that's going to trigger, right? We're going to use that method with the object to be able to access the value determined from the inner class for min, max, and average. So now what you have would be the output following that 1, 9, and 5, and it provides explanation. So to really think about is to look at the scope of your nested class. Is it possible to nest a class within a block scope, and how that would be localized? If you want it localized, it's not going to be known to the outside. Now, if you don't want it to be localized, you want it to have the outer access, then you don't want it to be localized. So on the next example, it shows you on how the inner class, the show bits is the inner class, and it's a local class nested within a method. So what we have is we have a class nested within the method here that's going to be localized. And so the outer will not be able to access that. So when you design this and you want to think about how your scope is going to be, which class is accessing which, and how you're going to be able to meet the objective of your program. So next we're going to talk about Var Arcs, which is variable length arguments. And this is a method that takes a variable number of the arguments based on the precise use, and you would simply create a method implying that it must be some way to create a list of arguments that is variable in length instead of fixed. So far we've used arguments that are fixed, but when you want to be able to have a list, a parameter list, or a list of arguments, you would use Var Arcs. So there are two things to really think about when you're working with this. Okay, one is that if the maximum number of the arguments was small and known, then you could create overload versions of the method. And although this is suitable, it would be narrowing the class in various situations. And secondly, the maximum number of the potential arguments is very large or unknown. We would want to use the arguments and put it in an array. So in this way, it is a list of arguments. It's an array of argument which would be passed to the method. So you can do it both ways. If you know the maximum number of the arguments and it's small and known, then you can just simply overload and be able to use it. Secondly, if you don't know the number of arguments, or it could be very large, then you would want to use the arguments and put them in an array and use the array to pass to the method. So here, since JDK5 is when this was implemented and it continued to be implemented for the later Java SE, so you have a variable length argument which would be short, that would be called Var Arcs. And now if the method takes a variable number of the arguments, that's going to call variable arity method, or called Var Arcs method. And the parameter of the Var Arcs method is not fixed, but rather it would be in length. Remember that it could be unknown number of the arguments. So in this example, how do we declare that, right? So we would have, this is a static method, and within this we would declare the variable length argument list. So you would have int is the type, and then to specify this within the parameter. Now v is the name, right? Then you then would print it, and we would use v.length to show the variable length. Okay, and since it would be in a group, we wanted to use the for loop to iterate through each and be able to output each of the argument value. So this is how we would be able to do that, to use the for loop and to be able to print the argument value. So now in the second example, this demonstrates the variable length arguments. So we have a class called Var Arcs. We have a static method, and we're using int v, and the ... here tells us that we're using Var Arc. So then again, we would have the number of the arguments would be the length of v, and we wanted to show the content using the for loop, so it's going to iterate through the entire group and show each of the argument value. Then in the main method, we then would be able to call VA test, which is the method that's specified up here. And so when we call that, it's gonna be able to show the length of the arguments and each of the numbers. So when we call that, we would have 10, which is one argument, 1, 2, 3, which is 3 arguments, and for your no args, which is empty. So when you call different numbers, we would then include the value as arguments in the parameter here. So when it output, it's going to show number of arcs is 1, content, arc 0, 1, 0, and so forth. So as you can see the output. So on the first one, we have only one argument. The value is 10. The second one, we have 3 arguments. That's its length. And the value is 1, 2, 3. On the last one, we have 0 argument, nothing. So this shows you on how you can use Var Arcs and how to implement Var Arcs with Java. Also, on the next example, we would also use it. Here it shows you on the side note here, it's a normal and Var Arc parameter. So you would use string message, which is a normal parameter, and then you would use a Var Arc, which is using int ... and then its name v. You can name it anything you want, but the indication is the type. The ... shows that it's a Var Arc parameter, and to be able to, so similar to the last one, you would see that here, it's pretty much close to the last example. But in this one, what we did was in the method, the static method, we're using a regular or normal, right, argument along with the var arg parameter. So you can have them combined like that. And then lastly, we're going to talk about overloading Var Arcs method. So just like what we talked about with overloading earlier, we can change up the type of the Var Arc in order to overload the methods. Okay, so when we talked about overloading method earlier, just like, you know, regular overloading, we would be able to change up the type. So here in this example, what you have is you have a method that is a static method and it's using var. So the type of this the first version is int. Then the second version we're using Boolean. Okay. Now when we call it, when we put in 1, 2, 3, that is fine because they are integers, so that would pass as integer here. When we use true, false, false, that would be okay too because it's Boolean. But when you leave it empty, this is gonna create an error because it doesn't know it's ambiguous. It doesn't know the type. So now if it matches the type, you can have as many as you wish, a group of arguments like 1, 2, 3. I can have 5, 6, 7, 8, 9, 10, and it would still be able to output. And or if we have Boolean values like true, false, false, true, true, false, true, etc., it would be okay as we specified the type here. But if you don't have anything like this one, if the type is ambiguous, it would generate an error. So here, that gives you a little bit more explanation. And as you can see, the concept of overloading is the same. You can use the same method name as long as your argument type is different. And in this case, because var args is already a group of arguments, we can't say different number of arguments, but we can change up the type and be able to overload the var args as we pass it into the method. Okay, and this concludes my part 2 of CIS18A Week 4 lecture, which covers recursive method, recursive call, static variable, static method, static block, and var args, and how to overload var args in methods.